Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.
Hello, everyone, and welcome back to episode number 43 now of the How to Program with Java podcast. As always, I will be your host, and welcome back to this brand new year. If you're following along with these episodes live, this is now January 7th, 2014 is when I'm recording this particular show. And as luck would have it, come the nice cold winters that I get here in Toronto, Canada, I am starting to catch a cold. So my throat is starting to get a bit sore, and I'm hoping to be able to knock out this show before I, A, lose my voice, or B, just, get so raspy in the throat that I can't continue. So I'll try to be as brief as I can, but that's generally not what happens with these podcast shows. In any case, let's move right on into the 5-star reviews for this podcast. I had 3 come in, all from the United States of America. The first saying, I'm a senior Java developer with more than 8 years of experience, so they actually have more experience than I do professionally. I think I'm only around 6 at this point, maybe 7. They said a couple months ago I was looking for a podcast to help me improve my English. I came across Trevor's podcast, and it helped me not only with my English, but also to expand my Java programming knowledge. I really like your beautiful Canadian accent, thank you, and really appreciate your great effort. Keep up the great work. So that was from, I apologize, he's actually from Iran. He or she, I should say, are from Iran. It says from Mayran Hatami. I'm so sorry if I'm butchering your name. Interesting that they actually have 8 years of experience, and they actually managed to learn stuff from this podcast, which is actually targeted more so towards beginning programmers along the first episodes and whatnot. And that's actually something that I found as well for myself when I was going through the content to teach the content. I learned a whole bunch of stuff myself. So this podcast is not just for beginners, but for anyone who wants to go back and really cement their knowledge in programming. So that's awesome. Amazing feedback. Thank you so much for that. Another review came in from username Brigoon, B-R-I Goon, from the United States. They said, I took a Java class in college, but finished the class without really knowing how to do anything useful. Trevor's podcast is great. I have listened to them and am now starting on his video tutorials. Oh, great. I highly recommend these to anyone wanting to learn Java. Trevor makes it all easy to understand. Fantastic. I love that kind of feedback. Thank you very much. And the last 5-star review came in from, again, the US of A, from username, ASTIG8. Astigate? I don't know. It says the teaching style is what sets this apart from any other online training. God, these are such great feedback. Supplement this podcast with JavaVideoTutorials.net and HowToProgramWithJava.com, and you'll be cruising towards learning the Java programming language even without prior programming experience. So fantastic. I mean, those 3 reviews just sum up exactly what it is that I set out to do. I have no words other than just to say thank you to those 3 people who sent in those 5-star reviews. If you want to do so yourself, please go to howtoprogramwithjava.com/love, L-O-V-E, love, and share the love. Go to that URL, and you'll be redirected to my iTunes review webpage, and you can go and click on write a review, etc., etc. So please do that, and I'll be very happy, and I will read your 5-star review at the top of the next show. So, let's get into today's content. So today's content will be focused on the database relationships. We had sort of touched on database relationships in the last episode, where I talked about the most popular of the database relationships, and that was the one-to-many relationship. In this show, I want to focus on the 2 remaining relationships, which is the many-to-many and the one-to-one. So I'm going to just jump right on into it. Again, trying to be as brief as possible. There's tons of words and whatnot that I created and put together into something I call a blog post or the show notes. And that will be available at howtoprogramwithjava.com/session 43. That'll be the show notes, and there's going to be a whole wealth of information there with graphics and actual code for that, go along with this talk that I'm about to have, this tutorial that I'm about to give. So I'm going to be brief here, but I was very detailed in my blog post, so be sure to check that out. So the many-to-many relationship. The many-to-many relationship is a database relationship that's used in a situation where the rows in the first table can map to multiple rows in the second table and vice versa. So those rows in the second table can then map back to multiple and even different rows in the first table. Okay, so table A maps to table B in multiple ways. Table B maps back to table A in multiple ways as well. Many to many. All right, makes sense? If not, let's talk about a real-world explanation for that, because that could be a bit too general. I think of books and authors. When I went online to find good examples, I found this one. I loved it. Books and authors, or authors and books, whichever way you want to look at it. And you'd have to decide what the relationship between those two things looks like. So again, like I mentioned in the first episode, there's essentially two questions that I like to ask myself to determine what kind of relationship we have. So let's ask those questions. The first question is there indeed a need for a many side of the relationship? So this means that in the case of authors and books, can an author create many books, or can an author own many books? All right, so that's the answer to the question, or that is the question. Is there a need for a many side of the relationship? So can an author create many books? Well, the answer in my books, no pun intended, is that the answer is yes. Indeed, an author can have or create or author many books. So therefore, the answer is yes, we do indeed have a need for the many side of the relationship. But that's just the one side. What about the other side of the relationship? So that's where the second question comes in, is that, does the table on the many side actually only map to one item in the relationship? Okay, so in this case, if we're talking about authors creating many books or being able to create many books, does any one particular book only map back to one author? The answer to this is, I don't think so. No, because any book these days could be written by many different authors. Okay, there's tons of books, even programming books that are created and written by several authors. So since the answer is no to this question, that means that we're looking at a many-to-many relationship. Okay, so a book can be written by more than one author, and an author can write more than one book. All right, so there's a good little graphic again at on the show notes for this episode, howtoprogramwithjava.com/session 43. There's a good little diagram that shows exactly what this relationship actually looks like. But you'll have to go there to see it. It's just a picture of a books table pointing to an author's table with many hooks or branches into both. So that brings us along to how do we actually create this many-to-many relationship in SQL? All right, what does the table design or schema look like? So this is where things get slightly different from the more popular one-to-many relationship. All right, so a good design for the many-to-many relationship makes use of something called a join table. All right, so the term join table is really just a fancy way of describing a third SQL table that holds just primary keys. Okay, so with the one-to-many relationship, we looked at two different tables, okay, and there was only two tables where the second table held a foreign key that pointed back to the first table. All right, that was the one-to-many relationship. Now, the many-to-many, instead of having that sort of, design or layout, we're going to create a third table. All right, so let's say we have, author and book. For the the author and book tables. So there's two tables. One's named author, one is named book. In the author table, there is an author ID. and a bunch of other stuff, but I don't want to talk about that because that's not really relevant to what it is that we're talking about right now, which is the relationships. Relationships really only have to do or concern themselves with the keys. So we have an author table with an author ID, and then we have a book table with a book ID. So where does this third table, the join table, where does that come in, and what does it look like? So that's how the author and the book tables will actually look like. They'll have their own individual IDs. And since this is a many-to-many relationship, we are going to create a join table when implementing this relationship. So the join table is going to be created with a name. First of all, you need to name it something, right? So we have the author table, we have the book table. What's the join table going to be called? It's going to be called the author_book table. And that's sort of the convention. The convention is to just take the two individual names of the tables and just mash them together with an underscore to separate the two of them. All right. So in this case, we have the author_book table, author book. And that is going to be the name of our join table. But what's the contents? What are the contents of this join table going to be? Well, it's just going to be the primary keys of both of the other tables. So the author book table, the join table, is going to have an author ID and a book ID. Okay, the author ID points back to the author table. The book ID points back to the book table. So these two IDs are going to be foreign keys. And they're foreign keys because they are indeed keys, they're keys, but they are keys that belong to another table. They don't belong to the author_book table. They belong to individually their own individual tables, which is the author table and the book table individually. All right. So again, this is kind of complicated to explain by voice, so please check out the show notes. You'll see exactly what I'm talking about. So the join table will contain, like I said, the primary keys from the author and book table, and this is very important to do. So we have to have all of the keys in the join table that obviously relate to all of the tables that make up the join table. So like I said, the author ID and the book ID both have to exist inside of this one table for it to truly be a join table. Okay. Now, sometimes it's useful to assign another column to create a primary key for the join table. All right. Sometimes that's useful. It's completely up to you if you want to or not. All that would look like, it would be, a primary key for the author book table would be the author_book ID column. Okay, so you'd have the author book ID, you'd have the author ID, and the book ID. All right, so three different columns. One is the primary key, which is the author book ID, author_book_ID. And anyway, that gets pretty confusing. Just check out the show notes. It's very straightforward when you see it in front of you. Okay, so now that we've talked about the idea of a join table, how do we use it? How do we actually create the rows in there to actually establish the relationships, right? Well, this is where, again, in the show notes, I went through some examples, but to keep it very simple, let's say that I, myself, personally, Trevor Page, have created a book, and let's call it the How to Program with Java book, which is true, I did author that book. If you want to check that book out, you can go to javapdf.org and check it out, but that's, a whole nother topic. I created this book, and so what would that look like in my database? Okay, well, there would be an author. There's the author table. The author ID, let's say that author ID 1 points to me. Okay, let's say I have, first name and last name stored inside of the author table. So author ID 1 points to Trevor Page. And let's just say, to keep things simple, book ID number 1 points to the How to Program with Java book. All right, author ID 1, Trevor Page. Book ID 1, How to Program with Java. So all we would do to create that relationship, to tie both the author and the book together, you would insert a row into the join table. So you would insert into the author book, author_book table, because that's the join table, and you would insert those two values, author ID 1, book ID 1. Done. There you go. You have now created a relationship between the author table and the book table, and you have created it in such a way that author 1 is tied to book 1. All right? So let's say there's another author. Let's say there's author 2. And that author is someone who helped me create another book, a second book. Let's call it the, how to create a website book. Okay, so the how to create a website book is book ID 2. And let's say that both myself and this other author were co-authors when creating this book. So then we would have to insert 2 separate rows into our join table. We would insert into author underscore book, where author ID is 1 and book ID is 2. Okay, so that means that Trevor Page is an author of book ID 2, which is the how to create a website book. And we would insert again into the author book table, author ID 2, book ID 2. So now the second author is also an author of the second book, which is the how to create a website book. All right. Now here's where the many-to-many relationship really comes into play. Let's say that author 2 created a third book that has nothing to do with me. Let's say it has to do with, fishing or something like that. They wrote a book about how to be a good fisherman or something. And that could be the title of the book, How to Be a Good Fisherman. And that's book ID 3. All right? Are you following along here? So we have 3 books, 2 authors, and to create the relationship between the author and the book, you would say author ID 2, insert into author book, which is a join table, insert author ID 2 and book ID 3. All right, so having said all that, now what we can do is, if you wanted to, you could query that table to say, all right, I'm going to give you an author ID, and I want you to tell me what books that person has published or authored, right? So you'd be able to say, all right, with author ID 1, what do I get? And with that, you could say, okay, well, there's author ID 1 appears, 2 times, and the matching rows are book ID 1 and book ID 2. So if I said, given author ID 1, what books has this author created, you would get back book ID 1 and 2. So you'd be able to say, all right, this author created book 1 and book 2. And then, again, you could say, all right, well, given author ID 2, what books has this person written? It would give you back saying, well, author ID 2 has corresponding rows 2 and 3 for book IDs, which means that author 2 has created book ID 2 and book ID 3. All right, so that sort of satisfies exactly what it was that I have created. And you could also do it in vice versa too now, because it is a two-way relationship. You can say, given book ID 3, who were the authors who have created this book? And then it would say, okay, well, since there's, book ID 3 only appears, once, and it has one matching row, that means that book ID 3 points back to author ID 2, which means that author ID 2 is the only author for book ID 3, etc., etc. And then you can pass in book ID 2, and then you get 2 authors. Pass in book ID 1, you get 1 author. All right? There you go. Beautiful many-to-many relationship. It's made easy with a join table, but also difficult if you don't understand or don't follow the concept of a join table and why it's used. The important thing to know is that the 3 different relationships in general, so the one-to-many, the many-to-many, and the one-to-one, all have different special ways of creating the relationships inside of SQL and the way these tables are designed. All right, so the one-to-many relationship has the foreign key inserted in table B in the right-hand side of the relationship. All right, that's how the one-to-many works. The many-to-many uses a join table with the 2 foreign keys, 2 primary keys, inserted as foreign keys in the join table. And then obviously that brings us on to the one-to-one relationship. Okay, so now I want to end my discussion on the many-to-many, and I want to move on to one-to-one. And I want to say, well, then you must ask, what is it that's special about one-to-one with the way that it's designed or its schema is laid out? Again, schema is another word for the design of a table or a design of a database. Okay, you can say database schema or table schema, and that just talks about, if it's a database schema, then, what are the tables and what are the relationships between the tables, and et cetera, et cetera. So that's I keep throwing the word schema out there, and I don't know if I defined it very well or at all. So that's kind of what schema means. If I say schema, just think design, okay? So one-to-one relationship, how do I make that work? Well, first, let's talk a little bit about what a one-to-one relationship is. I'm assuming now, given what we've already covered, you should know, at least instinctively, what a one-to-one relationship is. But I'll give it an explanation. A one-to-one relationship means that you have two tables that have a relationship, but that relationship only exists in such a way that a given row from table A can have at most one matching row in table B. Okay, it can actually have 0 matching rows or at most 1 matching row. All right, so a real-world example, because I like real-world examples, would be between a person and a driver's license. So I looked at a bunch of examples online of one-to-one relationships. This is my favorite, so this is the one I'm going to use. Hopefully, you, wherever you are in your country or state or province, have something called a driver's license, which is something that allows you to legally drive a car or an automobile in some way, shape, or form. All right. So if one person, first you have to ask, can one person have more than one driver's license? Okay. Can one person have more than one driver's license? So in the case of North America, the answer is no. At least I think it is. For my country, it is. For the states, I would assume that's the case. It wouldn't make sense to have two different licenses, I don't think. But I'm saying in general, let's say it's given that in the case of North America, and let's say the world, the answer is no. Any one person cannot be given more than one driver's license. So any given person cannot have more than one driver's license. And then, well, fair enough. What about the reverse case? Can one particular driver's license be owned by more than one person? So I would say, again, in North America, and I would say hopefully most of the world, the answer is no to that as well. One driver's license cannot be assigned to more than one person. One driver's license is assigned to one and only one person. All right? So that means that for both of our little questions that we need to ask, the answers point to the fact that we have a one-to-one relationship. Okay? So that means that if I were to pick out any driver's license from, let's say, a huge pile of driver's licenses, if I picked out any individual license, it would point me back to one person in particular. All right? It wouldn't point me back to, multiple people or possibly multiple people. It would be one person for sure every single time. So there we go. That's a little description of one-to-one relationship. It's actually similar to a parent and child relationship, believe it or not, but I'll get into that. So I want to talk about how you create a one-to-one relationship in SQL. So the trick to creating the one-to-one relationship is to identify which table is the right-hand side of the relationship. Which table is on the right-hand side. Another way to determine this is to say which table is the child table in the relationship. Okay? Which is the parent, which is the child. So this is usually done by deciding which object can exist without the other. So in other words, ask yourself this question. Can a person exist without a driver's license? Right? Which object can exist without the other? Can a person exist without a driver's license? I would say yes. I would hope so anyway. Anyone can exist without a driver's license. I'm assuming when you were first born, you were not born with a driver's license. So that would mean that, it doesn't mean that you don't exist because you don't have a driver's license. You absolutely exist, but you exist without a driver's license. So then, how about the other side? Can a driver's license exist without a person? I would say no. I would say that you cannot have a driver's license that exists that doesn't belong to someone. All right? So there are obviously special cases there if the person passes away or something like that, but I don't want to talk about those special cases. I just want to say that in general, if you have a driver's license, does it belong to a particular person? I would say that yes, it does. So therefore, we've sort of identified which one is the child in this relationship. So the child is the driver's license, because the driver's license cannot exist without its parent, which is a person. Okay? So, parent-child relationship, whichever way you want to look at it, it could be a one-to-one, a left and right, or a parent-child, whichever one suits your fancy, go with it. So, like I said, the parent in this case is the person, child is a driver's license, and you'll find, I think, with most one-to-one relationships, that's the case. You have a parent-child relationship. I can't think of one where it's not, but for most cases, that is the case. All right. So now that we've decided that the driver's license is the child in this particular one-to-one relationship, we can move forward with our table design. So when designing the SQL tables for the one-to-one relationship, you'll need to make sure that the child table's primary key is also the foreign key of the parent table. Okay, very confusing to say, very easy to understand when you see it. So check out the show notes. So this means that the driver's license table's primary key should actually be the person table's key. So in other words, what we're going to have is like this. We have the person table, and the person table is going to look completely normal. It's going to look just like you think it would look. Has a person ID, first name, last name, birth date, whatever. Okay, plain old simple person table. Because the person is the parent, we don't have to screw around with the table design in any way, shape, or form. But because the driver's license is the child, we need to mess around with it. Okay, so it's a child in this one-to-one relationship. So what does the driver's license table look like? Well, the driver's license table will have, instead of having a primary key in terms of, let's say, since the driver's license table, it would have the driver's license ID, that would be false. That's not how you would create this particular table because of the one-to-one parent-child relationship. All right? You would not create it with a driver's license ID. Instead, you would create the driver's license table with a person ID. And that would be its primary key, which would also be a foreign key. All right? So that means that as soon as you create a driver's license, you have to have a person that corresponds to the driver's license, right? So that means that you have to have a person ID that you can insert into the driver's license table that will point back to a person that actually exists. And that's it. There's no other primary key or foreign keys in that table. That is the only key in the table. It is the person ID. And that will force the table to abide or follow the one-to-one relationship. All right, so that's the key, if you will, no pun intended, to creating a one-to-one table relationship. So the parent side, the left-hand side of the one-to-one relationship, which is the person table, is created with a person ID. The driver's license table does not have a driver's license ID. It has a person ID as its primary key. Cool? Cool. So that is essentially all of the topics that I want to cover in terms of the many-to-many and the one-to-one relationships. What I have not explained yet, my voice is starting to go, but I still have a bit more to talk about. What I have not spoken about is how to actually enforce and create these tables with actual SQL code. And I think I wanted to touch on that today, but I'm not going to be able to. I'll have to do that in the next show. But we need to talk about the actual SQL code, because how do you create these tables? And how do you create these relationships? I know how to create the design. You know what the tables should look like, but how do you actually make it so that it does enforce these rules? And that's what I'll talk about in the next episode. All right? So before I end the show, I want to go on to the questions section, questions from a listener section. I had one question come in from a very emphatic listener of the podcast who goes by the name of Murphy Collins, and he asked two questions, and I promised him that I would answer it in this episode. I know he's waiting diligently to hear my response to these questions, so hopefully I'm able to answer his questions and also help other listeners out if they happen to have the same kinds of questions. So, from Murphy Collins, he says, I want to create a highly dynamic website with Java, which also has a powerful graphical user interface, a powerful GUI. How do I do this? Okay, that's his first question. The second one is, I also want to create a social messenger on smartphones, kind of like I'm assuming he means like a social network. He says for this social network, but I don't know which social network he's referring to. So he wants to create a social messenger on smartphones, and how would he go about doing this as well? So these are very broad questions. These are very generic questions. I could probably spend hours and hours and hours and hours answering very specifically these questions. But I'll try to keep it fairly generic so that anyone would be able to get something from these answers. So his first question, he wants to create a highly dynamic website with Java which has a powerful GUI. Okay, so the key things here is he said website and GUI and Java. How do you do this? Well, this is my cup of tea, if you will. This is my specialty. How is it that I go about creating websites with Java that can do stuff in general, right? So Java has frameworks that you can use to make this kind of stuff possible. All right, so Java has a framework called Spring, the Spring framework. You can also use something called the Struts framework, but I'm very familiar with the Spring framework. And the Spring framework, it gives you something called MVC, Model, View, and Controller. Model View Controller is something that I definitely have talked about in past episodes. So for yourself, Murphy, I would go back in my library of podcast episodes, and you'll find a bunch where I talk about Spring and talk about MVC, and those are all very important topics that you should listen to. I don't want to reiterate everything I said in those past episodes, but by all means, go and check those out. So Spring is used in tandem with Java as a framework that can be used to create websites to make the use, or not the use, to make the, what's the word I'm looking for? The interaction with websites through Java very easy. Well, I don't want to say very easy, but much easier than if you were to do it by yourself. Okay? So in other words, from ground zero. So reinventing the wheel. So the Spring framework and the Struts framework both work very well for laying down all of the important design patterns and functionalities that you can and that you will need in order to make a functioning website with Java. Now, Java only handles the back end of things, the business logic of things. Okay, it doesn't handle the front end, which is the presentation layer. It handles the business layer of things. So this is kind of why I'm assuming Murphy asked that he wanted to build a website with a powerful GUI, a graphical user interface. So what you can do here is I would fall back on knowledge of HTML and JavaScript. Okay, I use HTML, JavaScript for all the websites that I create, and that's what I use as my GUI. Okay, Java has a built-in GUI called, there's a couple. One is AWT and one is Swing, but I absolutely would not recommend those two things when it comes to building websites because that's more for native Java applications, which, Swing, and I don't want to say no one uses it because I know someone wrote into me saying they were upset that I had said in my book that, Swing is pointless and there's no point in learning it other than using it as a tool to learn the programming language. Apparently that's not true. There are people who have jobs where they just use Swing and Swing programming and stuff. So I won't say that it's useless, but I would not recommend Swing for a website. I would recommend going just to native HTML, JavaScript, and CSS and all the things that go along with creating a website and integrating it with Java. So how do you do that? Well, that's through a technology called JSPs, okay? JavaServer Pages. So JSPs are what you can use. They're essentially HTML files that allow you to put Java code inside of them. All right? So there's a lot of information about this that I teach in my JavaVideoTutorials.net course. It's probably a little ways through the videos. It's probably starting around video, probably in the mid-30s of the videos. So you'd have to go through a bunch of those first before you get to video 30. But if you want, go to JavaVideoTutorials.net. You can sign up for a free account, and then you can just unlock all the videos. There's one button, you can click on it, a small fee, you can unlock every single video, and there you go. You can go wild with learning about all the things that I just talked about. So for yourself, Murphy, your best bet, your best avenue to pursue for tackling the creation of a highly dynamic website with Java and a GUI is to go to JavaVideoTutorials.net, sign up for it, unlock the videos. You'll get tons of information about Spring, tons of information about HTML, JavaScript, and tons of information about everything you need to create an amazing dynamic website. All right? So there you go. Now, I also want to add that there are other technologies with Java that you can use to create web pages. Okay, not just Java Spring, but you can actually use something called what's it called? Java Faces or JavaServer Faces. It might be JSF, JavaServer Faces. Let me double check that real quick just because I should know this stuff. I've never used it before. Yeah, JavaServer Faces. So if I were to read that from the wiki article, JavaServer Faces, abbreviated to JSF, is a Java specification for building component-based user interfaces for web applications. Okay? Java specification for building component-based user interfaces for web applications. All right? So there's a whole bunch of with JSF, JavaServer Faces, and Ajax and all this stuff that you can read up on. I'm not an expert with JSF at all, but I definitely know that it exists, and it might be something that you'd be interested in looking at. Okay? So, having said that, moving along to the second question is his question about creating a social messenger for smartphones. How do you achieve this? How do you create a social messenger app for your smartphone? Well, unfortunately, that is a very difficult question to ask, or at least to answer, I should say, because when it comes to smartphones, every single one has a different flavor for programming. So if you are a Java expert, then you're probably going to be forced into programming with Android phones. Android phones use Java on their back end, so you could create native Java applications for the smartphone using Android. Okay, now that's not to say that you can't create applications on other smartphones, right? There's the iPhone, but the iPhone uses a different programming language called Objective-C. Okay, you can absolutely, if you know Java, you can absolutely learn Objective-C. I managed to do it fairly quickly, but that's with a lot of programming experience already sort of under the belt, right? So it took me a month or two to learn to the point where I could create an app and publish it in the App Store. Okay, so it depends on which phone you are wanting to create the app for. Now, that's not to say that you can't create one app and deploy it on all phones, because that's actually possible too. There's something called PhoneGap, GAP, that is a framework. I don't think it's PhoneGap anymore. I think it was purchased by another company. If I could do a search for PhoneGap. This is very unedited. PhoneGap.com. Let's see if it looks like it's still there. I thought it was bought by another company or something like that. But this technology allows you to, quote, easily create apps using the web technologies you know and love. So PhoneGap is a free and open PhoneGap is a free and open source framework that allows you to create mobile apps using standardized web APIs for the platform you care about. So in other words, you can create an application using HTML, CSS, and JavaScript and publish it to all mobile platforms. So any smartphone. So Android, BlackBerry, iPhone, Windows, etc. Okay, there's a bunch of different platforms you can deploy to. But I've used this before, and it's a little bit limited in what it can do. Maybe it has evolved since I used it. I think I used it in the beta period of the PhoneGap application. But again, it really depends on what you want to do specifically for your project. So if you want to create a social messenger type application, as long as you don't need to make use of any of the phone's special like native functionality, like for example, location awareness and stuff like that, then you might be able to do that. You might be able to just write an application using HTML, CSS, and JavaScript and be able to deploy it on phones. How you would create the actual application itself, I think that's what Murphy's asking, how you create the actual social messenger application. I can't answer that specifically because it's such a big question. It's a very long answer I'd have to give for how to create a social messenger application. What I would recommend is that you go through the steps to figure out what, like the step one. So how do you know what objects you should be creating, for your application. So if you're talking about social messenger, you need to ask yourself, okay, what's a description of what my application should do? So let's see, a messenger application should be like this. I should be able to, create a user account for myself. I should be able to add friends to my account. I should be able to then, once I've accepted friends and they've accepted me, I should be able to send a message to those people. With the messages I send back and forth, I should be able to keep a history of those messages. Okay? And what else? It should be in real time. All right? So now you go through that description that I just gave and you pick out the nouns. The nouns is the person, place, or thing inside of this description. So what did I say? I said user, so that would be an object. Friend, that could be an object. Message, that could be an object. Message history, that could also be an object. What else did I touch on? I said log in, but that's more of an action, not really a noun. I forget what else I said, but that gives you a basic idea of the objects at play here. Users, friends, messages, message history. And you go from there and you create, user objects with username and password, and you put in functionality for logging in. And for that, you need a database. If you're doing it on a mobile phone, databases on mobile phones typically use SQLite, SQLite, SQLite. So I'd look at SQLite and how you could use that for a mobile application. There are frameworks that allow you to easily incorporate SQLite into your application. They're called ORMs. I forget, if you probably just Google ORM for SQLite. Maybe I can do that for you. ORM for SQLite. Well, there's something called ORM Lite, which is a lightweight Java ORM, supports Android. Well, that's just for Android though. Anyway, I forget now. I tried it once. I dabbled with it once, very, very briefly, and wasn't a big fan, so I kind of jumped ship from the PhoneGap universe. But anyway, that's pretty much my bag of tricks when it comes to creating mobile applications, because that's not where I excel, but I certainly have a little bit of the surface knowledge for how you would go about creating the application. So hopefully, now that my voice is starting to go and my throat's starting to hurt a lot, hopefully that was of some use to you, Murphy. I know he's been really excited to hear this stuff, so let me know if that answers your question, and I'll be looking forward to hearing from you. So again, if you all have any questions at all that you'd like me to answer, I'm very much excited when I get a question from someone and they want it to be answered on the podcast. So by all means, shoot me an email at info@howtoprogramwithjava.com, and I'll try to get that into the next episode. Whew. So I think for that whole episode, I will say nothing more. My throat is now dry, so I will say Happy New Year to you all if you're listening in the present. Hope you had a wonderful holiday season, and I can't wait to see you guys in the next episode, where I will be talking about SQL and how to actually create the tables in SQL code and assign the restrictions or the relationships that I have just outlined. All right? Take care of yourselves. As always, happy learning, and bye for now.
Thanks for listening to the How to Program with Java podcast. Please visit howtoprogramwithjava.com for more useful Java tutorials.